now. Please.
This question to the management of the grid and ERCOT. One idea that has crossed my mind is to have the whole country be on a single time zone and have DC lines running across the country from east to west. I realize that from the point of view of the Texas politics that might not be a good idea to link ERCOT with the other two major grids, but it would seem to me that it would be a great improvement in terms of leveling the load, particularly the peak demand load across the country. And I just wonder if you have any reaction to this suggestion.
Well, I guess I have two. It actually, air conditioning load tends to peak in the 5 o'clock hour. And so as that, in the Eastern Interconnection, basically all of the states east of the Rocky Mountains and parts of Canada are interconnected in one grid. So I think what you see is that essentially as the time changes, or the sun moves across the time zone, the peak actually levelizes more by having different time zones. But it's really not as much a function of the time zone as it is the movement of the sun across the earth. From an interconnecting ERCOT standpoint, there are already a couple of projects that are under discussion that would add several thousand megawatts of additional transfer capability between ERCOT and the east, and one of them potentially with the west. The other thing that people don't realize, I think, is that we have 3 ties with Mexico, and of course they have different profile of their load usage than we do. And so there's some ability that, although they're not used as much as we'd like to see, they're more used for reliability backup. But there is the potential to transfer a few hundred megawatts between ERCOT and Mexico.
I can barely
Yeah.
see from here. Go ahead.
All right. The most of our experience is based on horizontal axis turbines. I suspect almost all commercially available or used wind turbines in wind farms are horizontal axis. I personally believe that the case can indeed be made for vertical axis wind turbines, and it is going to be much more economic and safer, and particularly in the offshore environment. I would like for you to modulate your comments vis-a-vis the possible use of vertical axis wind turbines.
This question comes up a lot. It's a great question. You know, there's a lot of companies that have tried to build a vertical axis turbine. And the good thing about them is that the power generation equipment and a lot of the mechanicals are at ground level versus being 80 meters in the air. The bad part about it are the engineering moment arms and everything on that equipment and the side-to-side motion, and it becomes like the bearing in a vertical pump or a vertical motor. They are very tough animals to keep made. I know all the major turbine manufacturers have looked at this vertical axis. We have people come in our office 2 or 3 times a year with a new vertical axis machine, and we just can't see them being proven. That's not to say that walking out of here, maybe somebody in this room or your company or something can finally come up with a widget, but it's all in that moment arm at ground level and trying to keep the bearings in the machine down there. So I personally would love to see something like it, because anytime, the 4 truisms in the wind industry is that the sun rises in the east, it sets in the west, you will eventually pay taxes and your gearbox is going to fail. And when a gearbox fails on a on a horizontal axis machine, 80 meters in the air, it's a $250,000 repair on land, and offshore it's $1 million repair. And on one of our wind farms last year, we did 152 of those. So, the math is starting. I'd like to see all the equipment at ground level from a safety standpoint and from an accessibility standpoint. We just have not seen a design that gets us there yet.
Okay. Kent?
Yeah, I recently had the pleasure of serving on a North Carolina Governor's Committee on Energy. And the committee just loved offshore wind as being the answer to everything and being very cheap and available. And it was very hard to even get anything moderate into the report. You guys haven't talked about offshore wind at all, so everybody loves it. Talk about it a little.
We built one and we operate one. We operate 36 3-megawatt machines off the coast of Holland. In fact, if any of y'all have ever landed in Amsterdam, raise your hand. Or the next time you go, sit on the left side of the plane, right before the plane crosses the beach, look out, and those are Shell turbines down there. It's a very interesting thing. It's like the old nursery rhyme, when it's good, it's very, very good. When it's bad, it's horrid. The wind blows a lot out there, and it's consistent and what have you. What people don't understand is that your installation cost on the capital side is about 2 to 2.5 times an onshore installation, and the maintenance of it is approximately 3 times an onshore installation. You don't really have corrosion problems. It's funny, we don't have that problem, but you have sea condition problems. And when a turbine goes down and faults out, you have 3 kinds of faults. One is it's going to reset itself. Number 2 is you can reset it remotely from a laptop computer or a control center. And the third is you have to send a technician out there. And in 2008, we lost 256 maintenance days at that wind farm because we could not make a boat to platform transfer of a mechanic or a technician. And people say, well, well, one of those stretches was for 31 days. And so if a turbine goes out and you have to get a technician out there, we waited 31 days until we could get somebody out there. And this is even having a crew boat that has a $1 million articulated computer and GPS controlled arm that makes that last because our technicians are always tied off until that last 18 inches between the boat and the platform. And so if the seas are over a meter, we can't land them there. There is great potential in the offshore. You see Google, North Carolina, I believe Google worked with y'all on that, with the energy backbones and the power lines and everything. The issue there is you still have all these environmentalists, you still have the bird issues. As a factor of national security, the FAA and NORAD and everybody is looking at their radar installations because it turns out a typical wind turbine causes a window in the radar. And so you have to work through, and there are people working on stealth turbine technology and everything like that. There's a lot of money going into that. So it's offshore is extremely daunting. I will tell you that over here, our production tax credit on the onshore wind farm is $22 a megawatt hour, which means every megawatt hour we produce, we get a $22 tax credit. Offshore Netherlands, it is a 92 euro per megawatt hour.
Wow.
But the economics and the return on that project are very similar to an onshore because of the upfront investment and the maintenance cost. It's probably more than you wanted to know.
If I could jump in, there's other issue. I mean, in offshore has fantastic advantages because you don't have such a high levels of turbulence. I mean, you have very nice uniform flow, but then you don't have the issue with the complex topography that we have online. The issue that limits in the United States is the fact that you have to have floating platform, and then you have to worry about the stability of those turbines floating, which is in Europe. they're tagged into the ground. So that makes a big difference in the number of turbines that we could deploy offshore as well.
You have a
Hi.
comment?
Yeah, two questions. One of them is, I've heard recently, probably on NPR, discussions about subsidies for wind production and whether that's a good investment or not. And not being knowledgeable on that, I'd love you to comment on that, one of the panelists or any. And the second question is, again, from the natural environment point of view, could you explain to us what some of the concerns are with regard to birds? And with insects, I'm thrilled that you're killing mosquitoes, but what about butterflies or other insects? And then in the marine environment, since I'm a scuba diver, I'm also curious about, besides increasing mollusk production, what other impacts there might be on the marine environment.
Too hot a topic for
I guess I've
anybody
been
to
voted
handle
again,
it.
so.
Come on, Dick.
Well, on the subsidy, you know, if you look at the overall economics on the subsidy, it affects your end result return by about 1 or 2%. So, you know, is it huge? I can't quite answer that. It does mean something to us. The big thing about the subsidy, though, is that it is good for 10 years, and it starts when you put the machine in production. However, right now, the U.S. subsidy, they only have it guaranteed through the end of 2012. Well, it takes, as I said, 6 to 9 years to build a wind farm, and so you're making a decision on something that you're not sure you're going to have that subsidy on down the road. So more than the money, it's the certainty of whether or not it's going to be there. And the subsidy, right now, you can either take it as a production tax credit, you can take an upfront investment tax credit, which is a one-time payment, or there's a cash grant. And if you take the one-time payment versus the over-time payment, it's just a bet of what your capacity factor is and how good your crystal ball is on the wind, and if you think you're going to be steady or be above. On the environment, what you find is that birds are very habitual creatures. They fly in very narrow flyways, and they are very, very predictable. So what we do is we go out there either with radar or a SODAR, or we actually hire environmental firms, and we go through a couple of years of bird migration patterns to see exactly how they go. And it's time of year dependent, and it's time of day dependent, both things. And so there are several things we can do. Sometimes it's as simple as moving a turbine by 50 yards. It is literally that different. Depending upon the bird and the height they fly and what have you, we can actually adjust what's called the cut-in speed and the cut-out speed, basically the speed that we start generating and the speed that we stop generating. We can adjust that. We can adjust the time of day that the turbine operates, because a lot of the birds go out and fly in the morning, and they feed and come home, and then they'll do it again in the evening. One of our turbines at one of our wind farms, we found several bird takes at the bottom, and we started looking at it. And what had happened is, during construction, where they had scooped out the ground to pour the foundation and then leveled it back off, they had left this little area that was indented, and it was raining, and it got wet, and there was a pond, and there was mosquitoes, your favorite mosquitoes in the pond, and the birds would come in, eat the mosquitoes, take off, and get hit. And so we filled in that hole, and guess what? Problem solved. And so there's a number of things. On one of the projects we are looking at, we actually found out that the birds were flying through our proposed site because they were being chased away from a state park by bears. And so the mitigation is we're bear-proofing the park to get the bears out of the park so the birds can stay home to eat and not go. And the state came up with that. You know, if we'd come up with that, we would have been drug tested probably. But there are neat ways to approach these things. And the bug thing, I'm glad you showed that picture, because literally we can tell on the performance of some of our machines when we have a bug buildup, And there are companies that go out and wash blades, and we hire them to go out and wash the blades. And so it's a very real thing, these very, very small things. We also had a first, and this is not environmental, but it was sort of funny, but it's not. You know, I always get these phone calls that something's happened. We've had base jumpers out the top of our turbines. We've had this, we've had that. Well, the big fires in West Texas this year, they were flying a lot of helicopter loads of retardant. And I'm not sure if it was on purpose or not, but we had a red turbine for about 6 weeks because one of the helicopters misdropped a load of fire retardant on our turbine. So it's just one thing after another. But
Christine?
Can I make a comment?
Yeah, sure.
Is that
Go
okay? I think very good. I think I would like to point out that in terms of the subsidies, this is one of the things that we were very excited about integrating the wind tunnel testing with multidisciplinary design, and that is because you could optimize the entire system in such a way that you could increase the capacity factor so much that then you could make it so profitable. So you don't really have to depend so much with those subsidies. I mean, that would be like an extra ice in the cake in a way. But the other thing with the birds, I saw once that the buildings, tall buildings, kill more birds than the wind turbines. So the numbers are quite low. I mean, if you want to see over the years.
back on the subsidy thing, I worry much more about long-term maintenance costs than I do about the subsidy, to be honest with you. You know, at the end of the day, we buy these machines for 20 years. We have to operate them for 20 years, and you know, and the banks expect their money back, and we expect a profit, and you know, at the end of the day, a better running machine, a more consistently running machine, a more efficient machine, is one that we're not going to have to fix as often, because every time you have to fix one of these, you open up a possibility to hurt someone when you put them up the tower. And the industry safety record, as I said before, has gotten a lot better, but it's still how can I touch that machine less times than I do now.
Go ahead, Christian.
I think he was there first.
You go ahead, you were there first.
I wanted to ask a question about California's greater incentives. We've got 8.5% of our generation capacity in Texas. How well have greater RECs, you called them, I guess that's renewable energy credits, how well have they worked in California? What's the record there on wind as a proportion of their electricity generation?
Their goal keeps increasing, which is interesting. It started off at like 10% by some such year. Schwarzenegger increased it before he left office, and it's been increased once again. I forget what the exact one is, but fun thing about California, this is where the wind industry started in the U.S. If y'all drive on I-10 between Ontario and Palm Springs, you will see one of every wind turbine ever designed there, because it's a wonderful testing area. The funny thing is that California has now been surpassed by Iowa with the total amount of generation installed. California also, for the longest time, had some weird rules that you could produce the electron in a green manner outside of the state, put it on a transmission line, bring it into state, then you could take the credit as a green electron. They're now setting limits on that only 25% of their total generation can be that. And so as a result, you're seeing more and more in-state generation being built, and some of the run-up in the price and some of the run-up at the REC price too is simply because these portfolio standards are here, and we're here, and they're not giving in the amount of time that they have to get there, and so all the prices will go up. But I can tell you, California is concentrating a lot on solar now, too. The wind is sort of off the table. It's not off the table completely, but the wind is second rate, and they're putting solar in now too.
Go ahead.
Yes, I was interested in the economics associated with the possibility of interconnecting our grid with neighboring countries and neighboring states. And one of the issues I was wondering about, I haven't seen numbers about this, but what percent of the energy that you generate is lost per, say, 100 miles or 1,000 miles that it must be transmitted?
I don't know that I know that number off the top of my head. It's obviously most of the ideas of interconnecting between the states would be some kind of DC tie, so that we can control the amount of power that flows over those. One of the projects that's been looked at to interconnect Texas to the east is a long DC line that would go from East Texas to a point kind of over in the Mississippi type area. And the losses are obviously a lot lower on those direct current lines than they are on normal alternating current lines that we have everywhere.
We figure a 2% loss within our wind farm from the turbine to the interconnect point, and then we figure, depending upon how far it goes, another 6 to 10% out on the main line going someplace.
Well, I see that what is happening is you're anticipating lunch. So let's thank our panelists. I want to thank you very much as the audience for your participation. The lunch, that will be your reward, will be served on Grand Salon. I believe that is that downstairs lobby level?